millennia. Okay, so these are some of the various examples that people have, scientists, researchers have actually discovered. So the first one is, okay, and at the same time, we have also the advances in computing technology. So since the first assessment report to the current fourth assessment report, you see that there's also a vast increase in the resolution of the global climate models that are being used. Okay, so progressively you are able to simulate the better represent the features. You see, like all of you may be aware that like if you live near the coast, if you live near the mountains, you experience different kind of climate. So if you have a very coarse global climate model, then all those will not be represented very well. So by having an increased spatial scale or representation of the global climate model, then it is hoped that you can get a better representation of the climate. Okay, but all this of course come with the expense of computing power, and some of the modern global climate models, they are typically like 100 kilometers. Even then, it will still take maybe many months to actually run a simulation of about 100 years to 150 years. Okay. So why do we want to? Of course, the reason for running the global climate models is that we would want to use it to explain what our observations. You see, so here I illustrate that how you can see that there actually would be very different climate models would produce different results still, but generally when they are able to represent the observation fairly well, you see from the charts here. But if in the lower chart, in the blue line indicates the global climate models run without the greenhouse gases incorporated in. So in that case, it doesn't really agree to the observations. See? So what this actually shows is that in order for the results from the global climate models to represent the observations, you do have to incorporate in the greenhouse gases, and that attests to the fact that the human-induced, the human greenhouse gases is actually quite mostly responsible for the global warming. Okay. So here further illustration that the global climate models are able to reasonably produce simulations of over the continental areas, okay, over large areas. Okay, the global climate models have been shown to do fairly well. Okay, but we of course over a small area like Singapore. Okay, I will go into it shortly, and I will where there's a lot of interest because governments want to be able to adapt to conduct impact studies locally. So they're actually interested over the changes over a small area of, like Singapore. So how do we go about doing that, you see? Okay, so but let's talk about climate change scenarios. Okay, so in order to develop climate change scenarios, you actually have to have some idea of how population, how energy, how economic models will evolve into the future. Okay, so the next thing, of course, is from the emissions. You develop how the greenhouse gases will evolve based on your projections of population, economic models, and energy. And from there, you put the greenhouse gases, the projections into your global climate models, and from there, you actually produce your temperature, your rainfall, and your sea level projections. And if you want regional detail, then you have to subject the global model to the results from the global model into a regional model. Okay, and then subsequently from the projections at the higher resolution from the regional model, you provide it into your impact models for assessment to work out the impacts on flooding, on food supply, on biodiversity, on public health, on maybe your water resources. Okay. So I think I'm really running out of time. So I will just talk about this, the Ipcc scenarios. I mentioned earlier that we in order to make projections of the future climate, you need to have different projections of how population, how economy and will grow into the future, and how the adoption of fossil fuels and new energy sources are balanced out. So you have the Ipcc has developed 4 scenarios. Okay, the A scenarios are the one that are more economically driven, and then the B scenarios are the one that are more driven by sustainability. Okay, so these are the 4. Even within the 4 families of scenarios, there are actually even further classifications. Okay, which I will not go into here now. Okay, so for regional climate modeling, how do we do it? We start from the global climate models. We do a regional, and after that we go to regional climate models, and from there we use other techniques to statistically downscale to an area like maybe of our catchment area, which our maybe our PUB and our water, other agencies may be of interest to work to do the impact studies over the area to see how climate change will impact that area in the future. Okay, so we had done this particular study in 2007. This is the first one. Okay, these are the results that the findings that have been made available on the internet. For those of you who want to download this brochure, you can go online to download that. Okay. And I think with that, I will just wrap up my talk. Yeah. So if you have questions later, we can feel free to. Yeah.
Thank you, Mr. Loh. Our next speaker is Professor Euston Quah, who is an economist and head of the Division of Economics at NTU. He has a BA from Simon Fraser University in Canada, an MA from the University of Victoria, and a PhD from NUS. In fact, he was formerly the Vice Dean of the Faculty of Arts and Social Sciences here at NUS, as well as head of our economics department. And he was the founding director of the Singapore Center for Applied and Policy Economics, better known as SCAPE. Prof. Quah has spoken and written widely about climate change. To pick one instance, in 2010, he was invited as panel speaker on climate change and the economy by the U.S. Inter-Pacific Bar Association, which had previously heard from Al Gore and Minister Mentor Lee Kuan Yew. So, without further ado, Professor Quah.
Good evening, everyone. In the short 20 minutes that I have, I'm happy if you leave away at the end of this seminar with some of the thoughts behind some of the economic principles behind the global warming and climate change. Now, a caveat is in order, which is that seated on my desk in my office, there is a plaque. The plaque was given to me by graduate students in economics at NUS, and that plaque says, I am an environmental economist and not an environmentalist. Now, many times I get invited to functions and so on that people sort of mix up the two. Environmentalist is a person who cares a lot about the environment and pursues it with good intentions and so on, but doesn't worry or doesn't pay too much attention about the costs. Whereas an environmental economist presents two sides of the equation, the costs and the benefits. Now, I don't know how many of you in the audience are studying economics. And what is the first thing you learn in economics, which is that economics is a study of the allocation of scarce resources because of competing needs, competing ends. Now, if you take that definition, it simply means that all our resources, land, water, sea, material, non-material, they're all in limited quantities, but there's so many demands on the use of these resources.